I am Anil Kumar on request of students. Here is a test paper on sketching graphs for rational functions. I hope you find it useful. You can try these questions and then look into my suggestions. In case you want to learn from me, you can always send me an email on the address given and join my classes. Now, let us enjoy the journey of success. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we have a test paper on rational functions. I'll share with you 11 questions from past test papers, and I hope this will help you get good marks in calculus. In case you want to learn from me, you can always send an email on the address given. Let us now look into the questions. Question number 1. What is true about the function f of x equals to 3 over x squared minus 6x plus 5 as x approaches minus infinity? 4 options are given to us. Question number 2. What is true about the function f of x equals to 3 over x squared plus 6x minus 7 as x approaches 1 from the left side? Again, 4 options are given to you. Question number 3. Which of the following function has an oblique asymptote? Select from the 4 given. Question number 4. The graph of which function does not have a hole? Does not have a hole. Question number 5. Which of the following statements are not true about the analysis of first derivative? Question number 6. Determine all horizontal, vertical, and oblique asymptotes. Show your work. So 2 functions are given to you. Question number 7. For what value of k will f of x equals to x plus k over x have a local maximum at x equals to minus 4? Question number 8. Find the equation of the rational function from the given graph. Question 9. Graph the function f of x equals to x squared minus 4 divided by x squared minus 2x minus 3. Do not determine derivatives and therefore local maximum minimum. Now we'll do complete graph sketching in question number 10 and 11. Question 10. Use at least 5 curve sketching techniques to sketch the graph of the function f of x equals to 2x plus 10 divided by x squared minus 9. The last question here is to graph the function f of x equals to x squared minus 3 over x cubed. Analyze first and the second derivative for local maximum, minimum, and find the point of inflection. So those are the 11 questions for you. You can now pause the video, answer these questions, and then look into my suggestions. In case you want to learn from me, you can always send an email on the address given. Right? Now, let us look into the solution of these questions one by one. Here is question number 1. You can always pause the video and answer these questions. What is true about the function f of x equals to 3 over x squared minus 6x plus 5 as x approaches minus infinity? It means what? It means we're looking for horizontal asymptote, right? So clearly, there is a horizontal asymptote which is y equals to 0, right? Is the horizontal asymptote. Now, what happens when x is negative, approaching negative infinity? So you can sub the value of x as, let us say, minus 100 and check. You see that. Do you get a positive value or a negative value? Of course, the value is going to be very small. So clearly x squared being positive here will get a positive value when we approach even negative infinity. So that means f of x is greater than 0, right? As x approaches minus infinity. So we are going to approach from above. You get the idea. That is how you decide. So you can substitute, calculate, or either otherwise think. Question 2. What is true about this function as x approaches 1 from left side? So this time let's factor the function, right? So we have 3 in the numerator. Product of two numbers being minus 7 and plus 6 is sum. So clearly it is x plus 7 times x minus 1. So we have vertical asymptote at x equals to minus 7 and also at x equals to 1. So now we have to analyze what happens when we are approaching 1 from left side. So you can find the limit of this function as x approaches 1 from the left side. What do you notice? Well, that limit approaches which value? So when I take a value which is less than minus 1, in that case, this quantity will be negative. Since it is negative, we are approaching negative infinity. So option D is the right option. Perfect. Let's move on and take question number 3 now. Which of the following function has an oblique asymptote? So oblique asymptote is there when degree of numerator is 1 higher than the degree of denominator, right? So that is the condition for oblique asymptote. Here it is denominator's degree is higher, same degree. Now part C, degree of numerator is 1 higher. So that will give you oblique asymptote. Let's look into question number 4. The graph of which function does not have a hole? Does not have a hole means we do not have a common factor in both numerator and denominator, correct? So let's factor. So if I factor the first one, what do I get? We get x plus 3 times x plus 1 over denominator is 4 times 2. So x plus 4 times x plus 2. So no common factor, right? In numerator and denominator. So clearly, we do not have any hole in this particular case. And so we can move forward. Question 5. Which of the following statements are not true about the analysis of the first derivative? So, statements. More than one could be the answer of this particular case. Let's try to understand them. A. If first derivative is 0, then there exists a local maximum or a local minimum. Is this statement true? First derivative could be 0 if I have a condition like this. Do you see that? So do we have a local maximum minimum here? Not at all. And therefore, this is incorrect. And that is part of our solution. Right? Not true. B. First derivative is 0 at the point of inflection. Well, point of inflection means change in concavity, right? So is that true? I don't think so. This is concave down, this is concave up. So you can clearly see here the first derivative is not 0, and therefore this statement could be false. C. First derivative is 0 at a saddle point. So saddle point is a point where something like this. Do you see that saddle point? So the saddle point is kind of like this, like a horseback when you sit on, right? So this is correct. The first derivative is 0 here. So this statement is correct. D. First derivative test is important to find the point of inflection. Not at all. It is the second derivative which is important, right? So these three statements are actually incorrect. Only one statement is correct. So I hope that serves good purpose. We are ending our multiple choice questions. This was a very tricky question indeed. Let's look into question number 6 now. Determine all horizontal, vertical, and oblique asymptotes. Show your work. So you know what is the horizontal asymptote here? Horizontal asymptote is y equals to half. The idea here is, how do you show your work? Well, you know, degree of numerator denominator being same, it is the ratio of leading coefficients which is the horizontal asymptote. And in this case, it happens to be half. Well, the way to show this is, you could take x squared common, right? So we could write f of x as equal to x squared common, we get 1 minus 1 over x minus 2 over x squared. You get the idea. And x squared common in the denominator also leaves you with 2 plus 2 over x. Now you can cancel x squared, that's one part. See what happens. This is basically equal to what? This is equal to 1 over 2 when x is approaching infinitely large value. Because we are looking for horizontal asymptotes, we are looking for infinitely large value. It could be positive or negative. But in either case, it approaches half, and that is the justification. You get the idea. Now, to get the whole or a vertical asymptote, we need to factor. So, we are going to rewrite the expression after factoring. We get x minus 2 times x plus 1 in the numerator, denominator being 2x, x plus 1. And since one of the factors cancel, we do have a whole at x is minus 1. But if x is minus 1, what is f of x? Well, minus 1 minus 2 is minus 3. And then we have minus 2 here. So it is 3 over 2. Minus minus cancel. So that is how you have to figure out all these things. In the second case, degree of numerator is higher. So we have a vertical asymptote which is x equals to 5. To find the oblique asymptote, let's divide. So we'll divide 2x squared minus 3x minus 5 by x minus 5. So in that case, what do we get? 2 times, so we get 2x, right? So 2x squared minus 5x. Taking away gives me plus 2x minus 5. And when I substitute plus 2 here, I get 2x minus 10, and then substituting, we get the value of plus 5. So we have an oblique asymptote also, correct? Which is y equals to 2x plus 2. You get the idea. That is how we are going to answer this question. I hope concepts are absolutely clear at this stage. You can always send an email and contact me to understand the topics better. Let's move on and take question number 7 now. Question 7. For what value of k will f of x equals to x plus k over x have local maximum at x equals to minus 4. So what does that mean? It really means that the derivative at minus 4 is equal to 0, right? So this is what it means. So we know the function, which is f of x equals to x plus k over x. Let's find the derivative. So derivative of this function will be 1 derivative of x and x to the power minus 1. That means negative k over x squared. So that becomes the derivative of this function. Now we are given that at minus 4, it has to be 0. So it is 0 at minus 4. Let me substitute minus 4 for x and calculate. So we get 0 equals to 1 minus k over 16. So we can now get the answer. K over 16 equals to 1 or k equals to 16. Does it make sense? That is how we are going to answer this particular question. Now, let's look into the next question, which is question 8. Find the equation of rational function from the given graph. So, very interesting graph. We have two vertical asymptotes. Let's find the equation of these. X equals to 1, and this one is x equals to minus 1. So, the function I could write f of x equals to, in the denominator, x plus 1 times x minus 1. Clear? Now, look for the x-intercept, which is at minus 4. So that means in the numerator, we have x plus 4, correct? So that is because of this x-intercept. That is how we'll link the things, right? And then you can test it out using some value. Let's say the maximum local, which is close to 0. If I put 0 here, I do get minus 4, right? So we know f of 0 equals to, in this case, minus 4. So that is the point slightly below the local maximum. So it seems to be absolutely correct. We'll definitely get the maximum value at minus a small value, correct? So I hope this concept is absolutely clear, right? Move on. Question 9. Graph this function. Do not determine derivative and therefore local maximum minimum. So basically you need to factor this function, right? So we have x squared minus 4, which could be written as x plus 2 times x minus 2. Denominator being x squared minus 2x minus 3, which basically is x minus 3 times x plus 1, correct? So you have all this. Now, we have two vertical asymptotes, one at 3. So I'm going to sketch this vertical asymptote here. The other one at minus 1. So we have x equals to minus 1 and x equals to 3. You can find zeros or y-intercepts also because, okay, so let's put 0 there for x. So we get what? 2 times minus 2 over minus 3 times 1. So it is 4 over 3 with a negative sign. So minus 4 over 3. So y-intercept is slightly less, minus 4 over 3 it is. So, okay, let's say this much. Okay, now we can find the x-intercept, that is numerator 0. Numerator is 0 at plus and minus 2. So at plus and minus 2, we have x-intercepts. You see that. And that clearly defines our graph. We have degrees are same. So we have horizontal asymptote, which is y equals to 0. So let me also sketch the horizontal asymptote, which is right there. Right. Now to sketch this particular function, it is good practice to take some value, right? If x is 4, so what is the value of the function? So at 4, we'll get what? We get 4 plus 2 as 6 and 4 minus 2 as 2 over 4 minus 1 is 1 and then 5. So we get 18 over 5, a positive value. At 4, 18 over 5 is 3 point something, right? So kind of here, right? So definitely we can now sketch the graph of the function. Also note that if x is approaching negative infinity, the numerator and denominator, will they be approaching positive or negative? This is what you need to figure out to get an accurate graph. So I'm drawing the center part for you, which is approaching like this. Okay. What I need to do is you need to figure out when x approaches minus 1 from the left side, then f of x approaches what? When x approaches minus 1 from the right side, what happens to f of x? Similarly, you have to do these calculations for x approaching 3 from the left side and x approaching 3 from the right side. Figure out what happens to f of x. And then you will be able to sketch the accurate graph. You get the idea. Perfect. So that is the key for this particular graph. Now we have an x-intercept. You can actually plug in minus 3 also and find a point. So you could also find the value of function at minus 3. That is going to give you minus 1 minus 5 over minus 6 over minus 2. So you see this value is positive. You get the idea. This value is positive, right? So this graph does cross this point and we get a positive value at minus 3, right? So when you substitute, we clearly get a positive value, and therefore, what do you notice? So let's put minus 3 a positive value, which is 5 over, which is small but positive, right? So let's say like this. Let's take a value which is between minus 2 and 1. So if I take a value minus 1.5, also calculate for y minus 1.5. In that case, what do you get? We get negative here in the numerator, and in the denominator, we get negative, which is positive, right? So we get a function which will help us sketch this graph like this. You get the idea, right? So when I take negative infinity here, I mean a value which is very close to between minus 1.5. So minus 1.5 will give me positive, negative, negative, negative. Do you see 3 negatives? And therefore, we have a function which is going to be kind of like this. Let me redo. So that is how you're going to get the graph of this particular function. So I hope the concept is clear, right? Now, if you were finding the derivatives, you would have got the local maximum and the point of inflection also. Here is question 10 for you. Use at least 10 curve sketching techniques to sketch the graph, right? So it has a horizontal asymptote. So we can write the function f of x as 2 is common, x plus 5 in the numerator, and we have x plus 3 times x minus 3 in the denominator. So I like you to actually sketch this particular graph. It may look like something, plus and minus 3. So you have obviously vertical asymptotes as shown. I like you to do all the calculations, including the derivative, okay? And then sketch the graph. The right side is kind of like this, and the left side is decreasing and kind of like this, right? So that is how it is. And since we have a 0 horizontal asymptote right there, do you see it is going this side? So that is the horizontal asymptote. And you need to now figure out how does this work out. So I'm leaving this portion for you to test. Find derivative. and then also the local maximum, then sketch the curve, right? Do you see that? So I'll leave this as an exercise for you. Similarly, here is question number 11, where again you have to find first and second derivatives and then sketch the curve. So I'm leaving this question also for you. You should be in a position to sketch this particular graph. Is that clear to you? You can always find the solution of these in one of my videos. So let me kind of give you the graph of this particular function, which may look like, one vertical asymptote is there at x cube, right? So the graph will look like this. It is a very typical graph, but you need to find all these points. So test derivatives and the second derivative, and then follow algorithm, right? And then graph. So I'll end the video at this stage, leaving these questions for you to figure out. That is the major exercise to be done. And I hope with this, you'll get good practice for your test on graphing rational functions, right? So let's graph rational functions. Okay, so I hope you find these videos on these questions interesting and useful. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'll be great. Thanks for your time and all the best.